Hello, welcome to this webinar. My name is Paul Sanford. I'm the chair for this webinar, and nitrogen fixation in subterranean clover is vital to the productivity of grain and livestock systems in southwest WA. But is it doing a good job under current cropping practices? And it's my pleasure to introduce Perry Dolan, who will hopefully be able to answer this question. Perry's research presented at this webinar was also delivered at the Australian Agronomy Conference in 2017. And before I go, I'd like to invite you to type in questions throughout the presentation, and we'll address them at the end. Thank you, and over to Perry.
Thanks, Paul. Yes, before I get started, I'd just like to acknowledge the funding of GRDC and through the Grain and Graze 3 project. So I wanted to start with a bit of context. And firstly, even though there are a range of pasture legume species grown in Western Australia, subclover continues to be the dominant legume. And many years ago, Paul Sanford actually did a survey and surveyed 184 paddocks in the southern part of Western Australia. And he showed that the nitrogen fixation was quite good, averaging around 72%, but there was a huge range. Now, since then, there's been some additional challenges to the health of the system. And firstly, there's longer phases of crop and can be up to 6 years of crop before going back to pasture. And as we know, the rhizobia needs a host, and long phases of crop can put stress on the rhizobia. We also know that a number of herbicides can influence the growth of subclover, and SUs and Lontril in particular. The third one, we also know that acidification is continuing to occur, and this increased soil acidity also puts stress on subclover and also the rhizobia. Now, certainly lime has come in to correct some of these issues, but still soil acidity remains an issue. And lastly, there's been reluctance by some to inoculate when re-sowing. So the aim of the study was to examine the health of the nitrogen fixation process and relate that to current management and soil fertility factors. So just moving on to what I did. So last year, I surveyed 21 paddocks, mainly centred around the West Kendanup area, but I had 3 sites around Cranbrook. And I purposely selected these paddocks to look for diversity. So firstly, diversity in rotation history. So some paddocks that had long phases of pasture compared to other paddocks which had a short phase of pasture. I also looked at diversity in herbicide use and the resowing history and inoculation use. So what I did at each of these 21 sites was to firstly measure visually the pasture composition twice during the year, in winter and spring. I also looked at nodule numbers and rated them in a 1 to 7 scale. And I collected nodules to then identify the rhizobia type, and that's using the Mouldy ID technique. In the winter sampling, I also took soil samples and measured them for chemical analyses. And then in spring, I looked at the nitrogen fixation process, and that involves collecting both subclover and ryegrass, so a legume and the non-legume, and then comparing how much nitrogen is fixed compared to what's taken up from the soil. And then finally, to get an overall estimate of the nitrogen fixation, I estimated the total biomass, and that comes from pastures from Space Plus. So looking firstly at the rhizobial strain results, this graph shows firstly that WSM 1325, which is the current commercial rhizobia, is the most dominant rhizobia type in those 21 paddocks, with over 60% of the sites having that strain. But there are also a number of paddocks which had the older types, and as you can see the dates of those released, but a number of sites also had nodule type with the new one as well as the old types. And there was one site, WSM297, which is an exotic strain of Rhizobia. So looking at in a bit more detail, in terms of looking at the history of the site, I found that the current Rhizobia 1325 was found at sites where it had never been applied before. And so what this suggests is that this Rhizobia does spread in the environment, and that can occur via vehicles, via machinery, and also via livestock. This spread is helped by the fact that subclover actually seeks out 1325 even if it's in low numbers. But for a number of sites, for a minority of sites, it did have a problem competing with older strains. So if we turn our attention to the soil fertility, and in general, these soils had moderate to high fertility. So the soil pH, firstly, on average, was okay, around 5. But there was one site which was quite low, of 4.3. Now, if we look at the total inorganic nitrogen, again, that measurement is quite low, and that's useful when you're trying to maximise nitrogen fixation, because we know with subclover that there's a feedback mechanism, and when inorganic nitrogen builds up in the soil, then subclover fixes less nitrogen. But that figure of 29 is quite low, so that's promising for nitrogen fixation. And the other measurements there, P, K, and the organic carbon, all are particularly high, indicating the moderate to high fertility. Now, turning our attention to nodule numbers, and what I did was to use a rating system developed by Ron Yates. And this rating system varies from absent with 1 up to abundant with a rating of 7. Now, for my sites that I sampled, the average was around 5, so it's moderate. And all of the sites had sufficient nodules to fix nitrogen. Now, there was 3 sites which had the minimum, which in my survey of scarce, 4.1. And those 3 sites, 1 had a low pH, 1 was waterlogged, and 1 had root rots. So obviously all of them impacting on the number of nodules. Now, if we turn our attention to the nitrogen fixation data, so if we focus on the average column there, total biomass was 9.5 tonnes per hectare, so that indicates that that it's a very productive season and also a very productive environment. Now, the percentage subclover was 60%, so again, particularly good, but it did vary from 40 to 80. Now, if you go through the calculation, the total biomass by the percentage subclover gives you a total of 5.7 tonnes of subclover biomass. Now, in that biomass, the nitrogen percentage was 2.6%, and so again, going through the calculation, that gives you a total shoot N of 148 kilograms per hectare. Now, of that, on average, 95% was fixed, so that again is particularly high, and so 148 times 95% gives you that 139 kilograms of nitrogen fixed in the top. So that indicates, comparing that to other studies, that is particularly high, and as I say, that's 1 year of nitrogen fixation. But I also wanted to put out the min and max for the shoot N fixed, and that varied from 79 to 221 kilograms. So there was quite a large range, and that's predominantly because of the percentage subclover. So the weed content can decrease the amount of N fixed. So just a couple of couple of photos. The photo on the left shows a very productive subclover pasture with around 80% subclover, and the one on the right is where weeds have infested the pasture. So putting the the data onto a graph looking at the legume biomass in tonnes per dry matter per hectare compared to the amount of N fixed, you can see that there's quite a good relationship, and with an R squared of 0.6. And the slope of this line is this figure here of 20.36. But in general, what this means is that for every tonne of legume biomass per hectare, that you get 20 kilograms of nitrogen fixed per hectare. And this result is consistent with a review paper published by Murray Yankovic in 2010. So for farmers trying to maximise the N fixation, the first thing to look at is healthy plants, and especially healthy root systems. And if farmers can dig up some roots and have a look at the nodules, and as I say, you can rate them in terms of that rating system that I showed, but also to look at if the nodules are pink. And if you have nodules and they are pink, then that indicates a healthy nitrogen fixation process. And then from there, it's about maximising your legume biomass. And so to do this, you need to have a reasonable plant density, and especially pastures after crop is where the density can be low, and so it's important to supplement the seed bank with additional seed. But the second part there is the composition, and that's quite a critical part, is to try and reduce that weed content. And then nutrition and pH can affect the productivity of the plant, and so it's important to get that right. The third point there is to reduce the soil nitrogen, and what I mean there is about this feedback mechanism with subclover. So if there's high soil N, then that can reduce nitrogen fixation, and the way to reduce soil N is to have sufficient crop history to drive that soil nitrogen down. But if there is a nodulation problem, then firstly consider the rhizobia type, and you may have some of the older types which can be less effective than the current commercial strain. Also look at soil and plant analysis, and as I said before, that they can influence the growth, and pH can directly reduce the growth of the rhizobia. The third point there is about looking at the history of herbicides and rotation. As I said, some herbicides can impact on the plant, on subclover growth. And as we know with rotation, long phases of crop can obviously reduce the host and reduce the amount of rhizobia numbers in the soil. The final point there is about seasons and soil texture, and many of our soils in Western Australia are light textured, and so they don't buffer against the stresses that occur with and the stresses can be pH and can be herbicides, and so they can impact on the rhizobia. So consider the soil texture, and seasons, obviously if we have false breaks, they can also influence the seed density. And finally, wherever possible, is to introduce that the current commercial strain, and so to inoculate. And so just to conclude my study, I think I've shown that nitrogen fixation, certainly last year in this part of the Western Australia, that the health of the system is good, and that's irrespective of the type of rhizobia, the herbicides, or the years of cropping. Certainly the current commercial strain 1325 is the dominant rhizobia strain, and it can spread quite easily, but there are some paddocks where it's not dominant. And other research has shown that this strain 1325 is very effective, but other strains can have variable effectiveness. So it's important to get 1325 into the system, and there's a tipping point there, and certainly when it's competing against these older strains, is that you need to build up sufficient numbers, and inoculation can do that. So I'd like to leave it there. Thank you.
Thanks, Perry. We do have 2 questions at this point. And I'll ask the first, are you going to follow up on crop biomass and grain yield of subsequent cereals, crops, to capture the increase in end fixation into the cereal rotation? And that was asked by Ben. So I assume there you're looking to see how much nitrogen is carried over to the following crops across these sites that you've measured last year.
Yeah, thanks, Paul. Look, I didn't carry that on to the following year, but previous research has shown that roughly around 40% is carried over to the first year after a legume pasture.
Okay. Hopefully that's an adequate answer. But yeah, in my experience, about 30% of the nitrogen would be carried available to a following crop. The second question is, if you have adequate plant density but poor rhizobia levels, I assume that's of the current commercial rhizobia, how do you re-inoculate with the new strain? Do you need to sow more seed, or can you just use the inoculum? So it's essentially asking how you can populate an existing established subclover pasture with that most effective 1325. That's the question I was going to ask. And that was asked by Dale.
Yeah, thanks, Dale. Yes, no, look, the best way to do it is to introduce more seed with the inoculant on. And so you've got the host next to the inoculum, and so you can build up those numbers. But there's also dry inoculum, and so that's another useful way. But again, the best way to get it into the system is to get it into the soil rather than top dressing. So yeah, so it's a matter of getting it into the soil. And as I say, it's good to have a host with it to build up those numbers as quickly as possible.
Yeah, it's good to hear that, Perry, because there's been quite a few people saying, well, just top dress with that dry inoculant, and I've always wondered how effective that is, and it seems that you're of the view that it's not, and it's better to re-sow a new cultivated subclover that's inoculated.
Yes.
Good. Emma, I can't quite say it properly, just says, great work, Perry. So they're obviously very impressed with your presentation and the work you've done, and I would also say that it's good to see that end fixation is still as good as it was back in the days when I was working in this field. We have another question. Can you show us the gross margin for legume pasture in the wheat belt? Jackie, if you can. So looking at gross margins for legume pasture, I'm not quite sure from what point of view, whether for crops, because it's complex, because you've got the livestock and the crop following the pasture. Do you have any sense of that, Perry?
Yeah, no. Thanks, Jackie. I don't. So, but as you say, it's quite complicated. But certainly, as you said, I think legumes can improve livestock productivity, and so there's an immediate benefit, obviously, and obviously also what you said is the flow on to the crop, and so the way to do it obviously is to look at the amount of urea you're saving or nitrogen fertiliser you're saving, but remembering that it has a direct impact on the productivity of your livestock as well.
Yeah, I mean, the one statistic I like to quote is that if you look at the wheat yield across the whole of southern Australia, that I think nitrogenous fertilisers only account for something like 5 or 10% of the nitrogen in that grain, and therefore the rest is coming from the soil, which a good part is due to legumes in the system. So these legumes are critical. Ashley Herbert's got the question, can you comment on the relative advantage of the new strains of rhizobia over the older ones in terms of nitrogen fixed?
Yeah, so that question, it depends, because we know that the old strains can be effective. Just that when there are stresses such as pH they can reduce the effectiveness of the older strains. And so it very much depended on one, season type, but also, yeah, the stresses that are imposed. And so it's not to say that the older strains don't work, because they do. But there are certain situations where they'll have reduced effectiveness, and that's hard to predict.
Okay, thanks for that. Rob asked the question. The questions are coming thick and fast, Barry. You mentioned that the newer strain has trouble competing with the older strains at some sites. Do we understand this? And if so, and is nitrogen fixation is generally good, how critical is this likely to be? So, you know, if you've got an older strain that's doing the job, do you need to get too concerned about introducing the new one? So, why is the new one not as competitive, I guess, and in some sense of if infection is good, why worry about the new one? That's Rob asked that question.
Yeah, so to me it comes back to the point about the numbers game. And so obviously the older strains have been there maybe 40 odd years, and so they have a niche there, and they've built up numbers. And so there's certain situations where that, you know, they just outcompete the new one if it's not re-inoculated. So at the sites I looked, there was perhaps a failing of the re-inoculation, and so that often pastures go in when the soil is slightly dry, or, you know, before the cropping, and so there can be a dry spell and the inoculant dies off. So that's one example where it can't compete against the older strain. But if the conditions are right and the re-inoculation is done properly, then, as I say, it's about a numbers game, and that can then get sufficient numbers to outcompete those older strains. And yeah, so I think I'll leave it there, Paul.
Okay, thanks, Barry. Can we just have a comment here from Ben that it's not just the dollar cost of nitrogen, it's also the financial risk of bad then, particularly in cropping frost-prone areas with cereal. So I just wanted to make that point. We have another question, which is
good.
R.E. Jackie's question. I'm not quite. Jason Stokes, a farmer in Geraldton, has paddock by paddock gross margin comparisons of various legume pastures versus lupins versus cereal canola rotations, and it's a very interesting set of data. So there's the offer there to boost some gross margins, perhaps. Now, do we have any more questions? No. Oh, no, wait on. Ooh, last one. Dale asked this: is there any past or current work looking at pasture re-establishment with the last phase of the cropping program? So in that last year of the cropping program, before you go back to pasture, is there any current work looking at that?
Sorry, Paul. I had Paul.
Oh, you missed it, did you?
Yes, I did miss a bit. There's a connectivity issue there.
Yeah, it jumps about a bit. Is there any past or current work looking at pasture re-establishment with the last phase of the cropping program? So that last year, is there any work looking at re-establishing that pasture that's going to come in the next year after that regeneration? Did you get it that time, Perry?
Yes, I have got the question. Yeah.
Okay.
Look, I'm not doing any work in that area, but I know some of my colleagues are doing work in that area, and even though it doesn't apply to sub-clover, certainly Angelo Loy has been doing some work with Fred Serradella and bladder clover in that aspect, and so because of their hard seedness and the way they break down, you can establish them in that year before without them germinating in that year, and then they're available to germinate that first year after pasture. With sub-clover, I mean, yeah, look, I know of people who put in a bit of sub-clover in the year before and going back to pasture, and that works to some extent. It just, yeah, it's dependent on the crop yield, and also the season. Thanks.
Okay, I think this is truly the end of the questions, and we're getting to the end of we've got 3 minutes to go. So I'd like to thank people for attending, and also to thank Perry for giving a great presentation. And as I said earlier, it's great to hear that end fixation largely is doing the job in his part of the world. Do you have any last minute to say, Perry?
Thanks, Paul. Yep, no, thank you, Paul, and thank you for everyone who joined up. So thank you. Bye.
Bye.